Hello children, in this video we'll be solving miscellaneous exercise of your chapter 2, that is relations and functions. In this we have 12 sums, so without wasting time let's solve these sums one by one. First question is, relation f is defined by fx equal to x square from 0 to 3 and 3x from 3 to 10. And relation g is defined by x square from 0 to 2 and 3x from 2 to 10. And we have to show that f is a function and g is not a function. So one method is that you take all the points into consideration, like from 0 to 10, and put in the respective functions and prove that this relation is a function. And similarly you can do it by in gx also and show that it's not a function. Just one thing keep in mind, whenever we have to say yes that it is satisfying some property or condition, then we can prove that generally without showing all the points. But when we have to say no, then we have to give at least one example. Other method is, you can show or find the function at some suspected points. Now what are these suspected points? Like as you can see, this fx is given a split function. It has split into two parts, x square from 0 to 3 and 3x from 3 to 10. So most common suspected points are the extreme points where this function has been split, like at 3 it is been split. So we can check at 3, is there any problem with this or at this point or not. So we can check fx at 3, this is given x square. So f3 is equal to 3 square, that is 9. And also it is given 3x. So f3 is in this case also 9. So they are equal. So we have checked at this point and it is okay. So we can say that from x, that is from 0 to 10, all pre-images have unique images. Therefore, fx is a function. Okay, no need to write all the points, because when we have to say yes it's a function, we say generally. Second is gx. So again at this we'll check at this suspected point, that is 2. So at this 2 we have x square as a function. So g2 is equal to 2 square, that is 4, and also it's given equal to 3x, sorry g, and at 2 it is coming equal to 6. So here we can see that with the pre-image 2 we have two images, that is g2 is 4 also and g2 is 6 also. Therefore we can say as a pre-image 2, okay, pre-image 2 doesn't have unique image, therefore gx is not a function. So that's it. Second question is, if fx equal to x square, find f 1.1 minus f1 over 1.1 minus 1. So fx is given x square, so we can easily find its value, like f1.1 is equal to 1.1 square, that is 1.21, and f1 is 1 square, that is 1. So putting in this, f1.1 minus f1 over 1.1 minus 1 is equal to 1.21 minus 1 over 1.1 minus 1. This is equal to 0.21 over this is 0.1. So this is 2.1. That's your answer. Find the domain of the function fx equal to x square plus 2x plus 1 over x square minus 8x plus 12. First of all of you should know what is the domain of a function. Domain of the function is the set of elements or the numbers which when we put in the function, it should not be imaginary, it should not be infinity. Imaginary numbers appear when some negative numbers are put inside square root, and infinity is there when denominator becomes 0. So in this case there is no square root sign, so it cannot be imaginary. But in the denominator something is there. If it is 0, then it will become infinity. So it should not be equal to 0. So let us check at what points this is equal to 0. So we remove those points from real numbers. Solving this, x square minus 6x minus 2x plus 12 equal to 0. This is x minus 6 minus 2 common, x minus 6, taken x minus 6 common, we get x minus 2 equal to 0. So equating them, so 2 and 6 are the numbers at which this denominator can be infinity. So our domain will be real minus these two numbers, because both are polynomial functions. Okay, their domain separately will be real number, their intersection will also be real number, minus where this denominator is equal to 0. Fourth question is, find the domain and range of the real function f by fx equal to root of x minus 1. Again, domain is a set of numbers which when we put in the function should not be imaginary and should not be infinity. It cannot be infinity because in denominator there is nothing, but it can be imaginary if this inside the square root this expression is negative. So to find domain, this x minus 1 should be positive, that is x should be greater than or equal to 1. So our domain is 1 to infinity. To find range, range is the set of numbers which we get after putting domain elements, that is called the output. So as we know, we can put only numbers that is greater than or equal to 1, and this is our function. If we bring to that side, x minus 1 is greater than or equal to 0, taking square root on both sides, so x minus 1 is greater than or equal to 0. This is our fx. So we can see this fx can never be negative, it will be only positive. So range is equal to 0 to infinity. That's your answer. Find the domain and range of the real function f defined by fx equal to modulus of x minus 1. So again, domain is the set of elements which when we put in the function should not be imaginary and it should not be infinity. Imaginary it will be only if we put negative numbers in the square root, but there is no square root. And infinity it will be if denominator will be 0. So there is nothing in denominator, that cannot be so infinity. So its domain will be real numbers. We can put any real number over there. It will never be infinity, it will never be imaginary. Range. Range are the elements or the numbers which we get while putting domain elements. So if you put real numbers in this fx, we'll never get negative numbers. So range is all the non-negative real numbers. That's it. You can write this in wording, what I have explained. Because it's a modulus function, so it can never be negative. So its range will be from 0 to infinity, that is non-negative real numbers. Sixth question is, let f is equal to x comma x square over 1 plus x square, x belongs to real, be a function from R to R. Determine the range of f. Okay. We need to find range. So let y is equal to x square over 1 plus x square. Let us write x in terms of y. So this is 1 plus x square into y is equal to x square. Y plus y x square equal to x square. Y x square minus x square equal to minus y. Y common, x square common, so this is y minus 1 is equal to minus y. X square equal to minus y over y minus 1. Or we can write y upon 1 minus y. Taking square root, this is square root of y over 1 minus y. Now this is a square root function, so this will always be positive because it cannot be negative. This quantity in the square root can never be negative. So y upon 1 minus y will be positive. A upon b will be positive if first case is y positive and 1 minus y positive. Second case is y negative and 1 minus y also negative. Denominator cannot be equal to 0. So taking that side, we get 1 greater than y or y less than 1. So combined solution is y belongs to 0 to 1. 1 is not included. This is 1 less than y or y greater than 1. So you can see y less than equal to 0 and y greater than 1, we don't have any solution because no number is there which is less than equal to 0 and greater than 1. So our answer is from 0 to 1. So its range is equal to 0 to 1. Seventh question is, let fg up two functions defined from real to real respectively by fx equal to x plus 1, gx is 2x minus 3, find f plus g, f minus g, f upon g. So simply this is the addition and subtraction and division of these two functions. So this will be equal to x plus 1 plus 2x minus 3. So this is 3x minus 2. And fx minus gx is equal to x plus 1 minus 2x minus 3. That is x minus 2x minus x. 1 plus 3 is 4. And fx upon gx is equal to x plus 1 over 2x minus 3. Just this should not be 0. Okay. So that's it. Eighth question is, let f is equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a function from z to z defined by fx equal to ax plus b for some integers ab. Determine ab. Okay. So this is your x and this is your fx, and it is defined by fx equal to ax plus b. So 1 is there in this function, so by putting x equal to 1 and fx equal to 1, let us see what we get. So this is one expression we have got, that is a plus b is equal to 1. We can mark this as equation number 1. 2, 3 is also there, 0 minus 1 is also there. Okay, let's use this 2, 3. So putting x equal to 2 and fx equal to 3. So in this, fx is 3 and x is 2. We get 2a plus b is equal to 3. Let us mark this equation number 2. So solving these two equations, 2 minus 1 gives us 2a minus a, b cancelled, 3 minus 1 is 2, so a is 2, and from equation 1 we can find b, that is by putting a is equal to 2 plus b is equal to 1, so b is equal to minus 1. So a is 2 and b is equal to minus 1. That's your answer. Ninth question is, let R be a relation from n to n defined by R is equal to AB. AB belongs to natural numbers and relation is A is equal to B square. Are the following true? Okay, first is AA belongs to R for all A belongs to n. It means if A is any natural number, will this AA belongs to the relation? That is, will A will be equal to A square? So relation is A B means A is equal to B square, where AB belongs to n. So first condition, let us check. Again, if we say yes, so we'll prove it generally. But if we say no, then we have to give at least one example. So in this case, I'm taking A as suppose 2, because A is given. So 2 belongs to R means, is 2 equal to 2 square? No, 2 is not equal to 4. So this first is false. Second part is AB belongs to R. Let us take 9, 3. Because 9, 3 belongs to R, as 9 is equal to 3 square. Implies BA belongs to R. Let us check now, is 3, 9 belongs to R? So 3 is equal to 9 square? No. So 3, 9 does not belongs to R. We write 2, 2 does not belongs to R. So 3, 9 does not belongs to R. So this is also false. Third case, AB belongs to R. Let us take 16, 4 belongs to R. Yes, 16 is equal to 4 square. Yes. BC belongs to R. BC 4, 2 belongs to R. Yes, 4 is equal to 2 square. Yes. Implies AC belongs to R. Now A is this, C is this. Is 16, 2 belongs to R? Let us check. 16 is equal to 2 square? No. So this does not belongs to R. So third is also false. I hope it is clear. Tenth question is, let A is 1, 2, 3, 4, B is 1, 5, 9, 11, 15, 16 and F is equal to 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Okay. Are the following true? F is a relation from A to B. Okay. Let us draw arrow diagram to understand it better. So this is 1, 2, 3, 4. 1, 5, 9, 11, 15, 16. F1 is 5. So 1 is related to 5. 2 9, 2 is related to 9. 3 1, 3 related to 1. 4 5, 4 related to 5. 2 11, 2 is related to 11. Okay, so first question is, F is a relation from A to B? Yes. Why? Because left hand side elements are belonging to A and right side elements are belonging to B. Second, F is a function from A to B? No. Now we are saying no, so we have to give one example. Because 2 is related to 9 also and 2 is related to 11 also. So which is not possible. Okay. Eleventh question is, let F be the subset of Z into Z defined by F of this AB to A plus B. AB belongs to integers. Is F a function from Z to Z? Justify your answer. Okay. So we are given F of AB. This is like X and this is our Y. So F of AB is equal to A plus B. We have to check whether it's a function or not. That is, multiplication of two integers is equal to their addition. Let A is equal to 1, B is equal to 2. So what will be F of 1 into 2? 1 plus 2, that is F2 is equal to 3. Now let us take F is equal to A is equal to minus 1 and B is equal to minus 2. So F of minus 1 into minus 2 is equal to minus 1 minus 2. That is F2 is equal to minus 3. So we can check here that 2 pre-image has two different images. We write as pre-image 2 has more than one image, therefore F is not a function. Twelfth question is, let A is equal to 9, 10, 11, 12, 13 and let F is from A to N, N is natural numbers, be defined by Fn is equal to the highest prime factor of N. Okay, so Fn is highest prime factor of N. So what will be F9? F9 we can write as 3 into 3. So its highest prime factor is 3. F10 is F of 2 into 5. So its highest prime factor is 5. F11. So this is the prime number itself. So this is the highest prime factor of 11. F12, which we can write as 2 into 2 into 3. So highest prime factor is 3. F13, it's again itself a prime number. So this is 13. So what we need to find? Range. So range of this F is these numbers, highest prime factors, that is 3, 5, 11, 13. That's your answer.